Welcome everyone and welcome to the channel in Make Studies Easier. This is our second video and let's firstly have a recap that in the last video we discussed about the physical quantities which we use in chemistry, which includes mass, time, temperature and volume. So mass units are grams, kilograms and ton, while the apparatuses we use are beam balance and electronic balance. Time is measured in seconds, minutes, and hours, and is separated stopwatch or stop clock. Temperature is measured in degrees Celsius or Kelvin, and its apparatuses includes thermometer, temperature sensor connected to data logger. Moving on. Volume. Volume unit is cubic centimeter or cubic meter or cubic densimeter, and the apparatuses includes measuring cylinder, burette, pipette, gas syringe, etc. Moving on. Now we'll be discussing the 12.4 of experimental techniques and analysis, which is separation and purification, as well as separating solid liquid mixtures. Separating solids from liquids. The type of separation depends on whether the solid is soluble or insoluble in the liquid. Now, what's soluble and what's insoluble? Solids that dissolve in liquids to form a solution are soluble. For example, sugar in tea or coffee, salt in seawater, it is dissolved. Evaporation can be used to separate soluble solids and liquids. Insoluble are the solids that cannot dissolve. Instead, they sink to the bottom of the liquid. For example, sand and soil in water. Filtration can be used to separate insoluble solids and liquids. Filtration. Filtration is used to separate insoluble solid particles from a liquid. Filtration's aim is to separate sand from a mixture of sand and water by filtration. The procedure is that firstly we pour the mixture into the filter funnel that is lined with filter paper. Collect the filtrate. Filtrate is the one which comes to us, which has all the way gone through the filter paper, which is right over here in the bottom, filtrate. And the one which is left over is the residue. Collect the residual and dry it on a piece of filter paper. Now when we'll dry the residue, so we'll get the sand. When you pour a cup of tea through a tea strainer, you are carrying out a filtering process. Evaporation to dryness. Seawater contains dissolved salt. In order to harvest salt from seawater, pans of seawater are evaporated to dryness using heat from the sun. The solid obtained by evaporation to dryness is not always pure. When all the water has been removed, any soluble impurities will be left together with the solid. Now, crystallization. The principle of crystallization is soluble substances are removed from water. The definition is if a saturated solution is heated to various temperature, the solubility is always increased. If that solution is allowed to cool, the excess of salt, which is dissolved by the temperature, is separated in the form of crystals. Now, seeing crystallization. The aim of crystallization which we are going to do is to obtain copper sulfate crystals by crystallization. Firstly, we'll dissolve the impure copper sulfate crystals in water. Step number 2, filter to remove any insoluble impurities, collect the filtrate. This is copper sulfate solution. Heat the copper sulfate solution until it is saturated. When the solution is saturated, leave it to cool and crystallize. Filter to collect the crystals. Wash the crystals with a little cold distilled water to remove impurities. Dry the crystals between a few sheets of filter paper. And here we'll get the crystals of copper sulfate. Many substances decompose. Decompose means break down to form simpler substances when they're heated strongly. For example, sugar decomposes to water and carbon when heated strongly. Most crystals, such as copper sulfate crystals, give off water to become powdery when heated. For such substances, evaporation to dryness is not a good method of separation and purification. Steps taken to separate sodium and sand. When we have a mixture of sodium chloride plus sand, so firstly we'll add water to dissolve sodium chloride. Then we'll filter the mixture. In the filtrate we'll have sodium chloride, and in the residue we'll have sand and some traces of sodium chloride solution. The one which is the filtrate, which is sodium chloride, we'll evaporate it to dryness and we'll get sodium chloride. And the sand, we'll wash it with distilled water to get the sand, as it is mixed with some of sodium chloride solution as well. Separating solids from liquids. Another basic method of filtration is decanting. Solids are allowed to settle at the bottom of the liquid and then water is gently drained off. Vegetables do not dissolve in water. When you have boiled some vegetables, it is easy to separate them from the water by pouring it off. This process is called decanting. Another example is when we wash the rice. So, we do decanting. This technique is used quite often to separate an insoluble solid which has settled at the bottom of a flask from a liquid. Centrifugation. Another way to separate a solid from a liquid is to use a centrifuge. This technique is sometimes used instead of filtration. It is usually used when the solid particles are so small that they spread out dispersed throughout the liquid and remain in suspension. They do not settle to the bottom of the container as heavier particles would do, under the force of gravity. The technique of centrifugation involves the suspension being spun around very fast in a centrifuge. This is, you can see, this is above is the centrifuge and the down is after the centrifuge. Whole blood is separated by centrifuging into blood cells and plasma. The plasma is at the bottom. Distillation. The problem with evaporation is that the liquid is lost. Now, if we also want the liquid, so what we'll be doing? Distillation is a method of separation that saves the liquids. Distillation is used to separate two miscible liquids. Miscible is liquids that mix, and immiscible means substances that do not mix together, for example, water and oil. Now, distillation is used to separate two miscible liquids like water and alcohol, soluble solids from liquids like salt and water. There are two types of distillation, simple distillation and fractional distillation. We'll be discussing both. Okay, so what is the definition as such of distillation? Mixture of liquid is heated, changed into vapors, and vapors are condensed back to liquid, leaving behind all impurities. Best purification technique remove all impurities but remove all kind of minerals as well. Now, if we talk about simple distillation, used to separate a liquid and soluble solid from a solution. For example, water from a solution of salt water, or a pure liquid from a mixture of liquids. Here, the components from a solution are separated on the basis of their boiling points. The method is, firstly we'll take the solution will be heated and pure water evaporates, producing a vapor, which rises through the neck of the round bottom flask. The vapor passes through the condenser where it cools and condenses, turning into pure water, which is collected in a beaker. That solution is called the liquid distillate. After all the water is evaporated from the solution, only the solid solute will be left behind. Glass beads for uniform separation. Anti-bumper granule to control the sound. Now this is the entire structure or the entire apparatus which is structured. Like firstly we'll have the flask, and then we have a Liebeck condenser, the thermometer is above, and here we have the conical flask underneath. So this is all I have described over here. Moving on. This is also same way. This is also a diagram for distillation. In this Liebeck condenser, this is the Liebeck condenser, and over here there are two sides of, one is cooling water out and one is cooling water in. Simple distillation can be used to separate the product of fermentation such as alcohol and water. However, more effective separation is used to use fractional distillation, where the liquids are closer to boiling point and a high degree of purity is required. Fractional distillation. This method is for miscible liquids with significantly different boiling points. Miscible liquids are heated in a round bottom flask, their vapor at their specific boiling points move up to a column, fractionating column, and are condensed into a liquid in a Liebig condenser. That liquid, after being separated, is then accumulated in a conical flask. An industrial use of the fractionating column comes in the refining process of crude oil. Separate individual gases such as nitrogen from the mixture we call air. Fractional distillation relies upon the liquids having different boiling points. When an ethanol and water mixture is heated, the vapors of ethanol and water boil off at different temperatures and can be condensed and collected separately. Ethanol boils at 78 degrees Celsius, whereas water boils at 100 degrees Celsius. When the mixture is heated, the vapor produced is mainly ethanol with some steam. Because water has the higher boiling point of the two, it condenses out from the mixture with ethanol. Now, this is the structure or the apparatuses we have for, or the diagram we have for fractional distillation. The difference only we have over here is of the fractionating column. It has glass rod inside with short lengths. Here we have it. An electric heater is safer to use when there are flammable liquids present. This is something very important to note down. The separation of the components in petroleum is achieved by fractional distillation on an industrial scale. Fractional distillation of crude oil is not carried out in school laboratories due to the toxic nature of some of the components of the crude oil. So here there was a question you'll see in the past papers which is related to methanol, ethanol and propanol. So after seeing the video, do solve the questions. Throughout the pharmaceutical, food, and chemical industries, it is essential that the substances used are pure. The purity of a substance can be assessed by its melting point, boiling point, and chromatography. Now, what is this chromatography? We'll discuss that. Assessing purity by boiling and melting point. Pure substances melt and boil at specific and sharp temperatures. For example, water has a boiling point of 100 degrees Celsius and a melting point of 0 degrees Celsius. Mixtures have a range of melting and boiling points as they consist of different substances that melt or boil at different temperatures. Melting and boiling points data can therefore be used to distinguish pure substances from mixtures. An unknown pure substance can be identified by experimentally determining its melting and boiling point and comparing to data tables. Melting point analysis is routinely used to assess the purity of drugs. For example, this is done using a melting point apparatus which allows you to slowly heat up a small amount of the sample, making it easier to observe the exact melting point. This is then compared to data tables. The closer the measured value is to the actual melting or boiling point, then the purer the sample is. Desalination. Now, what is desalination? In hot and arid countries such as Saudi Arabia, distillation is used on a much larger scale to obtain pure water for drinking. This process is carried out in a desalination plant. This desalination plant produces large quantities of drinking water in Saudi Arabia. Solvent extraction based on density. Immiscible liquids. If two liquids are immiscible, they can be separated using a separating funnel. The mixture is poured into the funnel and the layers allowed to separate. The lower layer can then be run off by opening the tap as shown. The blue liquid is more dense than the red liquid and so sinks to bottom of the separating funnel. When the tap is opened, the blue liquid can be run off. But this method is not very reliable. Some of the red liquid can also we have to be very careful in doing this experiment. We have to be very vigilant. Now, in the next video, we'll be discussing chromatography. So, if you like this video, so do subscribe to the channel for more such videos and do like the video and do let us know that what you want in the future videos. So, thank you for watching.